Hey guys, we are working on a 2004 Chevy Suburban today with a 5.3 liter engine. And what my friend Pete here told me was that it has a lean exhaust code. He just scanned it for me, said, hey, come down, take a look at it. That's all I know so far. Get you on the scan tool here. I'll put it right there. We'll go to engines. Go to our codes menu first, of course. Let's see what we're dealing with. History codes is what I picked. Both banks system lean. Okay. Next step, I want to look at our freeze frame data. I want to know what load and engine RPM this lean condition occurred at. So unlike other manufacturers, GM includes the freeze frame data within the OEM format. Other manufacturers, I would have to exit out, go global OBD2 to grab my freeze frame data. So there's some other codes in here too on the freeze frame. As you can see, we have a mass airflow out of range, engine miss, signal low, bank 2, sensor 2. But let's look at our lean codes first. The P0174, engine speed of 547. Map is 1.15, so this thing was idling for sure. My long term and short term, positive 25% on the long term, positive 10, positive 8 on the short term. You see the vehicle speed was 0, throttle angle was 6%. So this was an idle condition for this one, it looks like. Let's see what the 171 code looks like now. This is bank 1. I didn't pay attention to the temperature on the last one. This one's 143 degrees, map 131. Looks like we're idling again. Engine load's 2%. Throttle angle's 8%. Just a little bit cooler. So the throttle angle would be a little bit higher. This is probably a drive-by-wire system. So idle control is done with moving the throttle plate. Short-term, long-term, again, very, very lean. And we are in an idle condition here. 25% on long-term, 20% short-term on bank 1, almost 20 on bank 2. Engine speed 595. So yeah, these were both at idle, which suggests a vacuum leak. We'll see, not sure, but that's what it looks like. And I'm not going to look at all of these. I want to go back and read my codes again. So we have a mass airflow out of range, bank 2, sensor 2, signal low, bank 1 and 2, lean conditions, and an engine misfire. All right, next thing I'm going to do is pull up our data. And fuel trim data is what I'm interested in. Starting it. Feels a little bit rough at idle. You guys watch the short term here up top. So watch this one here and this one here. Now we just went into closed loop right there. So that's one of the ways you can tell right away as far as your loop status goes is look at your short term fuel trim when it starts correcting. Long term's at 16 right now, 16 and 18. Let's get my RPM up here so you guys can see it. It's down here. Okay. Raising my RPM. See an improvement on the long term, down to 14 and 12, 12 and 12, -6, -5 on the short term. That was at 2,000 RPM. 3,000 RPM. Well, this is definitely not as lean as the freeze frame data showed. We did have an improvement as I raised the RPM. And it's getting better too. Almost like there was a problem here that was corrected for, maybe partially at least. Yeah, this is almost to the point where it wouldn't even flag a trouble code at 15 and 14%. So what changed is the question. Do a visual inspection under the hood, maybe look at the air intake tube. And I know we had a mass airflow code too, but you can have, what you need to think about is you can have a vacuum leak that can set a mass airflow code because the numbers would be skewed. So if we're pulling air in through a vacuum leak that's going around the mass airflow, that's going to drop your voltage on your MAF, or your frequency in this case, and can flag a mass airflow code. So I still don't know yet. It could also be a mass airflow problem, but just things I'm thinking about. Look at these trim numbers. 13 and 14% is not going to set a trouble code. We use plus and minus 10% as a normal range. This is pretty close to that right now. I want to look at that freeze frame data one more time as far as temperature goes. I'm already past the 148 degrees that one data capture showed. Maybe we got to take this for a test drive too. Yeah, this one's at 206 degrees, so that makes me feel better. One of the things that concerns me about finding lean conditions is running the engine. Sometimes a lean fault can fix itself as the engine warms up. For example, an intake manifold gasket would a lot of the time seal itself once the engine warms up, because the intake expands and then closes off that leak. And so when you have cold engine only lean conditions or cold engine only misfires, it's one of the things I've listed in my book. Actually, in section 1, I tell you to look for an intake vacuum leak when you have a cold engine only misfire. So one of the things that concerns me about looking at a vehicle is engine temperature and when that fault set. It actually makes me feel very good right now that right here my coolant temperature is at 206 degrees, and I definitely have a pretty bad lean condition occurring. This is 25% on bank 2, 25% on bank 1, the long terms, and slightly positive on the short term, telling us the long term has reached its limit, and the short term has started to also correct to take into account for this lean condition. But engine was warm, which means I'm good to go. I can do whatever I need to do to try to isolate this. When we would be concerned, let me go to the other one and talk on that for a second. This bank 1, this P0171 fault, we had a lower engine temperature. Look at the coolant temperature. We're at 143 degrees. So when I see something like that, that makes me concerned that I might miss the lean condition if I run the engine too long. Okay? So things to look for. Again, for us, I have a hot engine lean condition, so that makes me feel a lot better about running the car, test driving it, doing whatever we need to do. You can see though that our lean condition is worse with the engine cooler. Long term is still maxed, but you see how much more positive the short term is. So I don't know. Think about that for a second. Let's look at the third one, the reason I came back in here in the first place. Let's see what temperature this one's set at. Coolant's at 143. It looks like this one is the same exact one. Let's see. Sometimes they do this. I don't know why GM does this. They'll have redundant fault codes or freeze frame pieces of data. This is the exact same data parameters. This is the exact same fuel trim numbers. Okay, so that doesn't really help me. But I do know engine was warm on the 1. That makes me feel better about locating this leak. Let's see what the mass airflow 1 looks like now. Again, idle speed. Maybe just off idle. Our throttle angle is 14%. We're only at 800 RPM. Let's see what the math showed. The grams per second was 9.96. My trims were very positive. The long term, 23%, 22%. 0 mile per hour. Hard to say what was going on there. 26 degrees Fahrenheit though, that's pretty cold. In open loop, mass airflow, circuit out of range. This could be an intake manifold gasket leak. Could be. That might contradict what I just said. As far as I'm safe to go drive it and whatever. Once we go back to the live data, we'll see what these fuel trim numbers look like. That'll give us some direction too. Okay, the one that I just looked at, so we're clear, was this mass airflow out of range, even though that box didn't show that I changed or that I picked that when I did. Jumping down to the engine misfire one now. Again, temperatures on my mind. 53 degrees. 53 degrees, and wow, look at our trim numbers. 25% on the long term, 37% on the short term. So again, even more lean condition. This misfire code that we have, I believe, is absolutely related to our lean condition. I don't think we have a misfire. In other words, I don't think we have plugs or wires or anything like that. This is some type of a vacuum leak condition. And the more I'm looking at this, the more it's looking like an intake gasket potentially. The O2 signal low bank 2 sensor 2, that's probably going to be a bad sensor. Yeah, and this is with a warmed up engine. This is with 197 degrees. Yeah, look at these trims during this code too. With the engine temperature warmed up, long-term 17, long-term 16, looks pretty good. This looks like 4.54 on the map. This looks like a wide open throttle. 64 mile per hour. Where's my throttle angle? 56%. This was under load. This is just going to be a bad sensor. If this was a bank 1 sensor 1 and bank 2 sensor 1, the upstreams that were indicating a low signal, then we could probably put these together with the lean condition we have. But being this is one rear sensor that's reading a low signal, that is most likely, given everything else that's going on, that is most likely just a faulty bank 2 sensor 2 that's behind the CAT sensor. We're not going to worry about that right now. We need to attack this lean condition. And it is looking more and more like a intake gasket. And the reason I say that is the warmer this engine has gotten, even through the freeze frame data, the better the fuel trim numbers have looked. And I think that may explain the mass airflow code as well. Say that we have a very large leak with the engine very cold, and that air again is going to go around the mass airflow and set a low mass airflow signal fault I don't believe we have a bad mass airflow sensor or a dirty mass airflow sensor. The data isn't there to show that. If this was a dirty MAF, as I raised my RPM, what we would have seen is we would have seen those numbers get worse. The fuel trim numbers would have climbed instead of dropped. Yeah, look where we are right now. I'm gonna have a hard time finding this this leak. We're at 9% and 11% with the engine warm. And the lopiness that I felt before, I don't feel it anymore. I may have to shut this vehicle off and wait. That one freeze frame data did show us a warm engine, and I know I said, oh, I'm confident I can go drive it, and I don't think I am anymore. I really think my best chance of catching this is to shut this off, let it cool down, do the other car that I need to look at, and let this cool off, and then put a smoke machine on this engine right away before I start it back up or do anything else. I think that would be what I want to do. We can do a quick visual under the hood. I think it's going to be pretty tough to find it right now. We can maybe do the quick water test on the intake. Okay, we'll do that. Water test, and then we're going to let it sit. I don't expect to find this with the engine warm, but I don't know, we'll see what happens. Oh yeah, absolutely. All down, look how rough the engine just got. Sweet. I can actually hear it getting sucked in. I'm gonna take you over to the other side too, see if we can catch it over there. I love the water test. It's so cool. I'll put some links in the description of this video for some other videos I've done using the water bottle to find vacuum leaks. Oh yeah, it's both banks. Look how rough the engine just got. Here, just look at the top cover. Real bad in the back right there. And of course that's making it misfire too, and pulling water into the engine. Some of you maybe are seeing this for the first time and you're concerned about me putting water into the engine. It's a very small amount, and essentially what we're doing is we're just steam cleaning the tops of the pistons. It's not a problem as long as you're not dumping water into the intake. In fact, years ago, I worked for a guy when I first started in the field, and it was actually something that these older guys would do, was pour water into the carburetor slowly with the engine revved up to take care of carbon deposits. Anyway, all right, see how smooth the engine's running right now? Just look at this top cover. I think the camera will show that pretty well. Now watch it. Watch how rough it gets. Get a little bit more water. Okay, let's do it again. Ready? Watch that top cover. It's the worst of the back part of the intake on both sides. Definitely an intake gasket, no question about it. I'm probably not going to use the smoke machine. I don't see a reason to. What I need to try to capture for you guys is a little bit better close-up shot of where this is getting pulled into this intake. Something else I can show you here too. Watch the exhaust. We have some steam coming out of the tailpipe. It's a little bit chilly today. Well, watch how much more is going to come out here when I put water in this intake. And what I'm doing, guys, is I'm just dumping water onto the intake manifold gasket area. I guess it could potentially be injector O-rings, and so I need to look at that a little bit closer. But injector O-rings is not going to match the lean condition that we have the colder the engine is. This is classic intake manifold gasket vacuum leak type symptoms. I looked up inside a little bit closer to see if I could show you guys this on camera, and there's really nothing I'm going to be able to show you. About the only thing I could show you is when I'm putting water on the injector O-rings, the water's still sitting around the O-ring. Maybe I can try to show it to you. Nope, there's not a chance that's gonna happen. Nope. Sorry guys, not happening. Since I couldn't show you the water getting sucked in, at least with the camera, I mean, you guys got to see the steam coming out of the tailpipe and the shakiness of it, and maybe the mic picked up the hissing that I heard. I'm doing the smoke test now for you guys, just so you can see it, just to prove it to you. Not necessary to do this. We proved intake gasket without the smoke machine. This is just going to help the camera. I have the air intake off and plugged, and you see the smoke that I'm using here. I am outside, so it might be a little bit difficult to see, but I don't know, we'll see. Taking the vacuum line off of the fuel pressure regulator to put the smoke into the intake, and that should provide us with some good visuals here in a second. We will see. You see the smoke coming up. I'll try to pinpoint this area for you. Get some light in there. You see it's on both sides. And this leak is going to be worse the colder the engine is. Because what happens is as the engine warms up, it seals up that leak and will actually idle a lot better. Actually, the customer's standing right next to me. I'm gonna ask him a question. When this thing's real cold, you notice it's real shaky at idle, isn't it?
Right, yes it is.
And when it warms up, it's a lot better, isn't it? That's exactly the symptoms we have. These intake gaskets will, once the manifold warms up, it'll expand and it'll pinch that gasket and kind of seal it. That's a pretty good shot on this front corner. And it's all along the whole gasket on both sides. There's a good shot of the injector O-ring. You see it's not coming out of that area. It's behind it. That might be our best shot, maybe. Cool. That sucks. Okay, so what are some takeaways here from what we learned? A few things. One is if you have a misfire when the engine is cold, that gets better when the engine is warm, that is suggesting an intake leak. Of course, the other one could also be a head gasket. I've seen that many times, where you have a slight head gasket leak and some water gets into a cylinder and wets the plug. You start it up and it takes a little bit to burn off that moisture before that plug starts firing normally. So those are the two main ones. Cold engine only misfires would be an intake leak, a head gasket. Fuel trim numbers that get better as the engine warms up, which is what we saw. We did have one of the data captures that was around 200 degrees, but most of them, as you saw, the mass airflow and the lean codes were occurring at very cold engine temperatures. One was like 143. I think the mass airflow was like 56 degrees. The misfire was like 20 some degrees. All pointed toward a intake vacuum leak. Then what we saw is we looked at our trim numbers and we looked at them at idle, and they weren't quite as bad as what we saw with freeze frame, but we raised the RPM in an attempt to see what kind of lean condition we had, and it proved again that it was an idle issue. So that says vacuum leak, and what we saw was when the engine warmed up, almost normal trim numbers, about 10%. So a lot of stuff to think about, but it's not too difficult when you have some practice at doing this. For those of you that don't really understand the fuel trim very well, I'll put a link in the description of this video for understanding short-term and long-term fuel trim. Again, I will also add a couple of links to some other videos where I've used water to find vacuum leaks, and any other video you find in there will be vacuum leak related, just to give you guys some other input, some other data to look at and really absorb the information. So again, look in the description of this video for that information. Okay, the final thing will be this Bank 2 Sensor 202 fault code. So I'll throw that up right there. This Bank 2 Sensor 2 fault code, which says signal low, that might be something that we don't want to do anything with until this vacuum leak is fixed. Although we did have a hot engine when we looked at the parameters for that. Let's take a look at the sensor. I'm probably not going to do anything with this right now because we really could fix all of this with just the intake. Fix the misfire, fix the mass airflow code, the lean codes, and possibly the low signal code on the O2. Now, why would it just be one downstream sensor? It shouldn't be. So that's suggesting the sensor's bad, but let's just take a quick peek at it. Okay, so this one right here, this bottom left corner, this HO2S Bank 2 Sensor 2 is the one setting the fault code. Looks like right now these cats aren't warmed up, so what you'll notice is the activity here is pretty high on these downstream sensors. Let me raise the RPM and warm this up a little bit. We'll see what it looks like. So now the question is, you see the difference in activity between the, wait, where's my rears? These are my two rears. This one up here is my Bank 1 downstream. There's the Bank 2 downstream. You see the difference in activity in this area in here compared to the Bank 2. Is that because the cat is more functional, or is that because the O2 is deteriorating? I'm not sure. You see, as the cats are warming up, how less frequent these downstream O2s are. See the Bank 2 Sensor 2 kind of flatline on us, flatline lean. The Bank 1 Sensor 2 is flatline more on the rich side, which is more what you want. Remember, the catalytic converter is going to catch and store oxygen and then use it in the process. So we don't want to have a lot of oxygen after the cat. And so this area in here where that sensor was lean, that Bank 2 Sensor 2 is suggesting that sensor is faulty. Just gonna get it nice and hot. And you can test the reaction of downstream sensors really the same way you do with upstream ones. If you do rapid snap throttle tests, you can force rich and lean conditions at those sensors, and then what that will do is tell you whether or not the sensor is alive. So you see I was able to drive the bank 1 rich up to 900, and you see how I can't do that with the bank 2. This sensor's bad. This sensor right here, this bank 2 sensor 2, can I reset the min-max for you guys? Okay, bank 2 sensor 2, I'm gonna do some snap throttles. Look at our max number. See how I was able to drive the bank 1 sensor 2 to 890 millivolts on these snap throttle tests. See how I can't drive that bank 2 sensor 2? And the sensor's still functional. I wonder if that camera moved. The sensor's still functional. I'm not worried about checking the heater circuit. We saw when we first started it, it was moving up and down. And I'm not worried about the signal circuit or the ground. Our issue is this sensor's not responding like it should be. You see my upstreams, I can max those ones out at 900. The bank 1 sensor 2, 894, and the most I could get is 760. And really during all of these snaps over in here, I was only going to 600 millivolts. So it's getting a bank 2 sensor 2 downstream oxygen sensor. I'll leave you with one last thought. Remember this, if you don't remember anything else. When you have the P0 171 and 174 fault codes, it's a lean condition. What we want to try to do is figure out when that lean condition occurred. If the lean condition occurs at idle speed, idle and low speeds, we're looking for a vacuum leak typically. And if that lean condition occurs at higher RPM, at higher loads, we're looking at fuel pressure issues or mass airflow sensor problems. Of course, there are other variables in there, but that's a guide that I use. Our freeze frame data showed us that. Exactly that. It was an idle condition. Our live data showed us it was an idle condition. And then what we saw was that it was more with the engine cold and got better with the engine warm. And so that was twofold. Now we know it's a vacuum leak, and now we know it's most likely an intake gasket type vacuum leak, because those are the only ones that improve as the engine warms up. The reason why: intake expands, tightens up, and seals off that leak. That's exactly what we saw. Remember the water test. Water test is awesome. And of course I showed you the smoke test because I couldn't get the actual camera in there to show the water being sucked in. So don't need a smoke machine. In fact, for this entire video, you don't need any fancy equipment, just a simple OBD2 code reader that would give you some data and freeze frame data, and then a bottle of water, and you could have done the job on this vehicle with no problem at all. So thanks for joining me, guys. I'll see you next time.